Good evening everyone. In today's session we are just going to discuss a very important theorem related to the geometry. This theorem is from the section of the circle, okay, and this is very useful just to simplify the questions of circle which are just which will be asked to you in any kind of examination like in school boards, in SSC, ND and CDS. So theorem says that angle subtended by any arc at the center of circle will be double of angle subtended by same arc at any point of the circle. I mean to say, in the question or in the theorem there is a circle, and you know very well that such circle will be having a particular center. So there is a circle with center O. Understand that there is a circle with center O. So theorem says that there will be an arc, any arc. So you know very well we need a chord to divide circle into different segments. So I am drawing a chord over here and there is a chord AB. So chord AB is just dividing the circle in two different arcs. One is a smaller minor segment and another is major segment. So the theorem says that angle subtended by any chord or any arc at the center. So this is the arc AB, this AB is the arc, and theorem says that angle subtended by the arc at the center, So angle subtended at center will be AOB. So this angle will be double of the angle subtended by same arc at any point of the circle. Okay, so I'm gonna to take any point on the circle on the opposite side of this arc. Understand that? So I'm taking a point C over here. So theorem says that angle subtended at the center will be double of the angle subtended by same arc at any point of circle. So what we have to prove? We have to prove that this angle is double of that one. Okay. So I'm writing here, we have to prove that angle AOB is twice of angle ACB. But we are just going to have three different cases to prove this theorem. Case 1 is that when angle is subtended in the major segment at the circumference. So you can see here point C is in the major segment. Okay. Second case will be when the angle will be subtended at any point which is situated in minor segment. Suppose the point is here in minor segment somewhere. And third will be when point is situated in semicircle. In all three cases, the angle subtended at the center will always be twice of the angle subtended at any point of the circle. Okay, by same arc. Understand that? So I'm going to provide you the proof related to this one. Okay, and proof is quite simple. To prove this, we have to draw a construction over here. So what are we going to do? We are just going to connect C and O. We are just going to connect C and O. Now we can see that there are two triangles. One is triangle AOC. First, I'm going to take triangle AOC. One is triangle AOC. Now you have to tell me what kind of triangle AOC is. I would say that triangle AOC is an isosceles triangle. Why isosceles triangle? Because we can say that OA will be equal to OC. OA will be equal to OC. I can say that OA is equal to OC. So I'm saying here that OA is equal to OC. It means this is an isosceles triangle. And if this is an isosceles triangle, if this is an isosceles triangle, it means two sides are equal. If two sides are equal, their opposite angles will also be equal. Understand that I am going to say you here that this OA is equal to OC. I mean then we can say that angle ACB, angle ACO will be equal to angle ACO will be equal to angle CAO, and let each of the angle is equal to x. So I'm saying here that if this angle is x, then this angle will also be x. Okay. Now tell me, AOC is a triangle over here, and you have studied about the properties of exterior angles of a triangle. You know very well any exterior angle of the triangle will always be equal to sum of its two opposite interior angles. Understand that? It means we can say that this angle, this particular angle, suppose this point is M. Okay, then I can say angle AOM will be equal to 2x, In the same way, Now we are going to move in another triangle, and another triangle is angle triangle BOC. So we are going to talk about triangle BOC. We are going to talk about triangle BOC. Now you can see in triangle BOC, this is also an isosceles triangle. Why this is an isosceles triangle, I can tell you, because we can see over here that this particular side OC will be equal to OB. OC will be equal to OB. Why equal? Because these are the radii of this particular circle. Understand that? And now this is also an isosceles triangle. So I can say that this angle and this angle both will be equal. Suppose this is Y, this will also be Y. So I can say that angle BCO will be equal to angle CBO, and let assume each angle is equal to Y. It means angle BOM will be equal to 2Y, because one exterior angle of the triangle is equal to sum of its two opposite interior angles. Now we can say that angle AOB is equal to angle AOM plus angle BOM. It means 2x plus 2y. 2 is taken common within bracket x plus y, and you know x plus y is equal to angle ACB. So we can say twice of angle ACB. So this is the case one, when point is situated in major segment, okay, at the circle. Understand that? So we can prove it. Now I'm going to discuss second case of the same theorem with you. Understand that? And you can calculate the third case on your own. Understand that? So case 2 says that when point is situated in minor segment, okay, so there is a circle, similar kind of circle, and this is a chord AB, and you know point will be in this major segment, and this is a point D. Okay, now we have to prove that angle subtended by the chord, this angle, is twice of this one. Okay, so we have to prove angle AOB is twice of angle ADB. So we have to draw same kind of construction. So we have to add O and D with each other. Okay, and we have to produce it. Understand that? Now here also we can say that OA will be equal to OD. Why equal? Because radii of the circle. Okay, we can say that. Now if OA is equal to OD, so opposite angles, this angle is x and this will also be x. In the same way, this outer angle, this outer portion will be equal to 2x. Okay, in the same way, OD is equal to OB. If this angle is y, then this will be y, and similarly we can say that this portion will be 2y. Okay, now we can say that angle AOB is equal to 2x plus 2y. 2 is taken common, so this is x plus y. Now we can say twice of angle ADB. Understand that? So this was a quite simple kind of theorem, and I discussed two different cases of this particular theorem to make you understand in a better way. Okay, we will meet you, okay, with the next theorem and with a new kind of question. You just keep watching, and if you are enjoying the things really, then let me know this. Okay, thank you so much.